How do you test and replace indoor or outdoor thermistors or sensors on EG4 electronics mini splits? How do you replace the outdoor unit's main controller or inverter board? How do you know if the main controller could be the issue? And how do you use your meter to test? You're watching Taddy Digest. I'm Tad, and today we're learning more about troubleshooting EG4 electronics mini splits. Let's get started. How do you take apart the outdoor unit to locate the sensors for testing and to locate the inverter board or main controller? We're going to start by using a Phillips screwdriver or a Phillips bit in our drill, and we're going to take the 9 screws that are screwed into this top cover. That way we can remove that top panel. I've already removed most of the screws, but we've got 2 on the sides, we got 3 on the front and 2 on the back. Take and remove that cover, and you'll notice there's an arrow, and this indicates the position of this cover, and that is for the airflow. So air flows through here. So we're going to take and line that panel up with the direction of the airflow to know we've installed it correctly. Now we're going to take the front panel off. That way we can get access to those sensors and actually see them, because we got a discharge sensor in here. So we've got 3 screws along the bottom. I've already taken out most of them. We've got 2 screws on the side. 1 here, 1 down here. And then we've got 2 screws right here on top. Once we remove those screws, I like to come over to this end, and I like to take and lift up and then pull it out. And then I like to swing it a little bit here and then lift up, and then you can remove this panel. Very easy. But you'll notice on this panel there's metal hooks with a little groove. So you do have to lift up, and they are placed inside of these metal holes. See? All right, on each side. Now, once you take off the front panel, the top panel, you can see the compressor. I've removed the sound blanket, and you can see one of the sensors. This is the discharge sensor, and it's on the outlet pipe of the compressor. This can be called a discharge sensor, or a high temperature sensor, or a exhaust sensor. Now, to get to where we can see the other sensors and we can actually access a bundle of wires that includes the plugs, we're going to take off this panel. So we've got several screws for this panel here, and you can see that they're near the access ports, and they're up here. There's 2 up here, and then around the back there's a couple which you can't see right now. But once we take out these screws, we can remove this panel here. And once we remove this panel, we'll have access to our wires. And we can see that we've got a black wire here, black plug, and this goes to our coil sensor. And then there's a white plug that goes to our ambient air sensor. And then we've got that red plug which goes to our discharge sensor. So I'm going to show you these sensors that are on the back side of this unit so you can get a better look. Here's the other 2 sensors. This is the ambient air sensor. As air moves through the coil, this sensor measures the temperature of the air. And then there's a sensor that's connected to the actual coil, and it measures the coil temperature. This is the coil sensor. So 3 sensors total, coil sensor, and to get to this one you really need to take this back panel off. To get to this one, you just have to take off the top panel and the front panel. This is the air sensor, and then this discharge sensor, you can get to this one, or exhaust sensor, that you can get to this sensor by just taking the top and the front cover off. Now that you can see these sensors, I'm going to run through testing these sensors. Now we can take our meter and we can place our leads on those pins. I've got 2 different types of leads. I've got my regular leads, which I can use to test those sensors, and I've got my micro leads. Micro leads are skinnier, so it's easier to test and get these leads on those pins, right? Because they're smaller. So we're going to use the micro leads. I'm going to take my meter, I'm going to turn the dial to ohms, and that is the upside down U. Now let's measure the resistance value of each sensor. This is the discharge sensor. So we're going to place our leads in the pins, and it says 54. Now we're going to measure the other two sensors, 10 kilo ohm sensors. This is the ambient air sensor, 10.37, and this is the coil sensor, 10.59. You can see how these resistance values for the ambient air and the coil sensor are just about the exact same. After using your meter to measure the resistance of this discharge sensor, we know this discharge sensor is a 5 kilo ohm sensor. And we may want to figure out, if the unit has been running, what the temperature of that pipe is. If you want to disconnect the sensor and then read the temperature of that sensor, that's one way you can know what the exact temperature is, or you can leave it on the pipe and measure the temperature of the pipe. The one way we can do that is by using a temperature clamp. This is a type of measurement tool for measuring that pipe. We can use this K-type thermistor and put this little sensor right here, or thermistor, on that pipe, or we could use a little infrared thermometer gun. This is the way we're going to do it. So we're going to take and measure that pipe, and let's see, 25.7 C, and you can see that red dot right there where that sensor is. So now we look at our chart, and our chart says that at 25.7 C, we should have about 55 ohms, right? And we could round up to 26, so, but 25, 55. So let's measure the resistance reading again with our meter, and then let's see if this chart adds up. This is my discharge sensor 5 kilo ohm chart. Verifying one more time, measuring with our meter, set to ohms, 59.2. So it's pretty close. It's not spot on, but we are measuring the pipe right next to that sensor, so maybe that's why it's a little bit off. So if yours is reading 100, and you know that, well, we should be right here, but we're way up here or way down here, then that's an indication that sensor's bad. Now we know that these sensors, the coil and the air sensor, are reading around 10 ohms. We can use our infrared thermometer, and we can put this right on that sensor, and it says 24.5 for the air temperature sensor, and then the coil temperature sensor, well, 24.5 because the unit's been off, and it's the same temperature pretty much everywhere in this building. Here's our sensor tables, our resistance charts, and if we look where it says 24.5, then we should be reading about 10, right? So if it's reading 3, then we know that sensor's bad when we check the temperature. So check your temperature, then check your resistance, and then you'll know when you check the charts. These are both 10 kilo ohm sensors. Okay, both 10 kilo ohm sensors. So let's go back here. Let's measure one more time with our meter, just so we know. Here's our coil sensor, 10.5. See that? Now this is our plug for our air temperature sensor, 10.27. Same thing for the indoor wall mount air handler, but I'm going to show you how to take that indoor wall mount air handler apart and get to those sensors. This is the main controller or main inverter board for the EG4 electronics outdoor unit. And this main controller comes as a whole assembly. So you don't have to apply thermal paste and worry about over tightening screws and installing an inverter board. You have a whole assembly. So this is the cover and the inverter board and then the heat sink already together. So I love the fact that we make it super simple for the installation process if you have to install one of these inverter boards. And a lot of your other brands of ductless equipment have just the board sent out with some thermal paste. And you run the risk of not installing the thermal paste correctly and then the IPM overheating and the inverter board being damaged, or over tightening the screws. So this is very nice. You have a few plugs that you have to connect to the board, but everything is really just plug and play. To remove the main controller, we've got a screw here, we've got a screw here, and then we've got 2 screws here. So that's 4 screws right there that have to be taken out. Before you can take the board out, it's good to take some of these plugs loose. So this is a plug that leads to the outdoor fan motor. This is the plug that leads to the compressor. I'm going to show you how to take these plugs and disconnect them. Now we're going to take and disconnect this plug by pushing this piece here in like that, and then wiggling it back and forth while pulling. Same thing for this plug. Push it back and forth, wiggle, and then this one is a little bit hard to do, and then pull. So those two are disconnected. I'm going to go ahead and disconnect all these screws now with my drill. So here, and then this last one here is, now you can see that this board, now there's some wires that are routed through the top. You want to take those off. Now we can turn this over, and you may want to take this off while this is flipped up that way, or while this is down like this. You may want to take this off. We can go ahead and do that like this. Now this is out of the way. Why do you want this out of the way? Because you can see the plugs that you got to take loose. Okay, so I'm going to show you. One is a blue wires that goes to a white plug that says 4-way. This is for our reversing valve. After you disconnect the plug for the 4-way valve, you go up here, you disconnect the plug that says UV and W. That's for your outdoor fan motor power. You can see it's not coming out. Why is it not coming out? Because we have this red piece of plastic in here preventing it from coming out. So what I'm going to do is I'm going to use these needle nose pliers and pull that piece out. Now I can take and push this little lever here and remove that plug. Now we've got our EEV valve plug, which is our electronic expansion valve. Take that plug off and lead it through the hole here. And then we've got 2 more. We got this plug here. This is for our indoor to outdoor communication. It goes to the 1, 2, 3 terminals. And then we've got our little communication board here. And we've got a blue and a brown. So what I recommend is using a pair of needle nose pliers. Take your needle nose pliers, put them right below where the blue and the brown wire connects into that spade, and then push that spade off, or that connector off of that spade. So now our board is disconnected, all except for a ground screw. See our ground screw that's connected to the plate where our terminal block is? Disconnect that ground screw, and then our old inverter board is out. How to test and figure out whether your main inverter or main controller is bad. The first test is simple. We take and disconnect the power. Anytime we work on this equipment, we disconnect the power for at least 10 to 15 minutes before we take the top off and touch anything electrical. So we turn the power off for 15 minutes. We take the top cover off the outdoor unit. Then we take the cover off of the inverter board. The first method is just observation. You're going to take a look at the board. If you see any burnt marks, this could be an indication that you have a faulty main controller. And right here, we have a burn mark. So that's an indication this main controller has failed and it needs to be replaced. Now, I'm going to give you the second method of testing. We're going to take our meter, and if you're using AC power to power this hybrid model 24K AC/DC EG4 electronic mini split, then you can measure L1 and L2 and you should have your 240 volts, right? We're going to take and we're going to measure with DC, right? We're going to take our dial on our meter and we're going to put it on volts DC. Now we're going to take our meter and measure from 1 to 2, and we should have 300 volts. 370 volts. Then we're going to measure from 2 to 3. And when we measure from 2 to 3, this is our communication. So it should be jumping around. And you can see it's jumping around, right? So it's communicating to the indoor unit. Anytime you measure from 1 to 2 and you don't have your 300 volts, and you measure from 2 to 3 and you don't have your communication jumping around, then this is an indication that you need to check your main controller or your main inverter board. How do you get to the sensors in the indoor wall mount air handler EG4 Electronics makes? I'm going to make this simple for you so we can get to those sensors and then show you how to test with your meter. So we take the front cover, we lift it up. We need to remove the Wi-Fi display board. So what we're going to do is we're going to take our screwdriver and take out this screw for that Wi-Fi display board, and then we're able to take and push this little pin here, this little plastic piece. There it is. There's our Wi-Fi display board. Make sure you take and disconnect the power. Now I'm going to go ahead and remove this front cover just to get it out of the way. So I take this piece and push it to the left, take this piece and push it to the right, then lift up, and your front cover is disconnected. Now we've got 4 screws in the front. 1, 2, 3, and 4. Then we've got a few more screws right here, but before I take those screws off, I want this vane out of my way. So I take this plastic piece, push it to the right, boop, push this one to the right, boop, and then pull this down a little bit, and then it will come right off. All right? So I got the vane out of the way. Now we lift up these covers. There's one here, boop, here, and then here. Those covers reveal screws behind the cover. So 1, 2, and 3. Now that those 3 screws are out, we can lift this up. But we're not going to do that yet. We're going to take this cover off. Why are we taking this cover off? Because I have to be able to route these wires through. I've got one for the Wi-Fi display board, and then here's my ambient air sensor, and that's one of the sensors we're going to use our meter and test. So route that sensor down, and then we're going to lift up the cover, and then we go back here and we lift up the back. Now on the back of the wall mount air handler, you can see that we've got these plastic pieces holding the back of this cover. So we're going to lift these up. Careful not to lift the air handler off of the mounting bracket, and make sure all these are off. Front cover should come right off. Route the sensor and the Wi-Fi display board through that cover, and then now we can see our other sensor behind this piece of plastic. There's our coil sensor. To access the PCB so we can get to the plug for the sensor, we've got a cover right here for that main PCB for this wall mount air handler. How do we access this cover or get this cover removed? We've got one screw right here. We're going to take that off. And then we've got a little plastic piece right here. See this? So lift this up and then pull this front cover off. Now we can access this PCB. Again, make sure you have the power disconnected. You don't have to remove the sensor for testing, but I'll show you how to remove it so you know how to replace it. So you take the sensor like this, and you just pull it out. See? And then you can put the new one back in. You'll need to have a cutting tool to cut the zip tie right here. Now I'm going to show you where the plugs are on the board for those 2 sensors. So if we follow the black wire into the board for the coil sensor, it's right here. So we can take and remove it very simply. Boop, like that. And then our ambient air sensor is right here. So we can take and remove this. And you can see where it's labeled. One's labeled pipe sensor, which is your coil sensor, and the other is labeled, it's hard to see it, but room sensor. Now we're going to use our meter. We've got it set to ohms, got our micro leads. We're going to test the ambient air sensor first. So place your 2 leads on the pins for the plug. Measuring the sensor, it measures 8.98. Now the other sensor, which is our coil sensor, we're going to take and measure that sensor by placing the leads on the pins, and it measures 9. So both of these sensors are 10 kilo ohm sensors. They read in the same range. The unit has been off. We can check our resistance charts, and then we can look at those values and know whether those sensors are good or bad. If a sensor ever measures OL, if it's a 10 kilo ohm sensor and it's reading 200, or if it's reading 0, then that's an indication that sensor is failed. Reasons for inverter boards failing early could be your voltage is too high. You need to make sure that you have an acceptable voltage coming to your mini split. Many times there are mini splits installed in the field and the voltage is already too high. And when there's a surge in that voltage and it goes up just a little bit, it ends up burning up the inverter board. So you got to make sure that your voltage range is acceptable for your mini split. So we're going to measure the voltage for this mini split. It is 238, and that's acceptable. But let's say my voltage was 255 or 260. That would not be acceptable, because anything in the 260 range could burn up that inverter board. Tips for making that inverter board last longer would be installing a surge protector, because if I have a lightning strike or I have a surge in voltage, some transient spike, then that can cause my inverter board to go bad. Making sure that you have the right maintenance in place. Make sure that somebody's cleaning that outdoor coil, and they're also cleaning the heat sink for the inverter board. Making sure that it's not dirty will make sure that you can reject that heat and that your board will not overheat and then ruin. Also, make sure that whoever installs your mini split tightens all the connections, because a loose connection can lead to issues with inverter boards and main controllers, like the one we have in our EG4 Electronics hybrid mini split. Hope you enjoyed today's video. Hope you learned something. If you did learn something, let me know in the comments what it was, because remember, questions can lead to content. But if you don't have a question, that's okay. Let me know who you are and let me know where you're from. If you liked today's video, hit the like button, subscribe, and smash that bell. Ding, so you know what I'm doing. And if you need a solar powered mini split like EG4 makes, definitely check out Signature Solar and use discount code Taddy50. You've been watching Taddy Digest. I'm Tad, and I'll keep you cool if you let me.